Hello, and welcome to another Rust and WebAssembly working group meeting. Thanks for coming out, y'all. So I switched up the agenda a little bit to put the binarian and emscripten items near the top so that folks who are only interested in those things can discuss those things, and then if they're not interested in the rest, can perhaps leave. And so I don't think we have anything in the RFC triage stuff. Why don't we jump right into the topic of binarian stuff, WASM2JS and WASMopt.
Hey, hi. Can you hear me okay?
Yep.
Cool. Yeah, so wanted to talk a little about that. One thing that we've been seeing is we see a bunch of cool things being done with Rust WASM on the web, and often the binaries are not optimized. So, I mean, typically it's just a matter of code size, but we've actually hit like browser bugs because of this. There was one on Chrome that, without running WASMopt, that had so many locals, it ended up triggering some V8 bug. So what I kind of wanted to raise here is maybe there's a place that we could document or actually automatically run WASMopt in the Rust sort of toolchain, but I don't know much about how that works.
So I'm actually really there. Ooh, I think I messed something up. So in the agenda, or you may not actually link, but in any case, so it actually is our intention that the standard Rust toolchain, which uses WASMPack, actually runs WASMopt automatically for you. And we have a PR to do that. That was the whole reason we added binaries a long time ago. It's just we haven't, it's been, development on WASMPack recently has been a little bit slow, but it's definitely our intention to run it by default. And it should be documented as well in terms of code size. So I'm actually curious as well. Everything that we've seen from binarian is that it shaves 20, 30, like a good double-digit percentage off of code size, but it doesn't tend to affect runtime performance that much. And so we haven't really documented it in terms of this is how to make code faster. It's more so how to make code smaller. Does that kind of match what you're seeing, or is it also like it actually accelerates what comes out of LVM even more?
It can make it faster, but it tends to help in these sort of pathological cases where you have like tons of locals or things.
Okay.
Otherwise, yeah, I mean, there's typically just WASM VMs are good enough with their SSA opts to do whatever needs to be done. So it's mostly code size, but the pathological cases are annoying.
Yeah, that makes sense. And I think it's also like because it's not run by default and because we're mostly Rust programmers who don't know how to build C++, it ends up being that if it's not always run by most applications, or like only if you run into size issues do you do it. And so for us, getting it running by default is the really important thing. So just whenever you type build, WASMopt is running in the background or running as part of the build. So it's definitely coming, that aspect of it.
Yeah, if there's anything we can help with. So there's also like, there's a JS/WASM port of it in binarian.js. I don't know if that makes it easier or better, but I guess we have the native stuff.
No, honestly, native binaries are perfect. We just need to thread through all the downloads to make sure it happens automatically.
Sounds good.
Just something we let slip a little bit. Go ahead. Yeah.
So you were also mentioning alone WASM2JS. Did you have anything in specific, or just like generally using WASM2JS?
Yeah. So moving on to that. So I wanted to mention that I finished like a large chunk of work on WASM2JS, fuzzing it, getting it, passing the emscripten test suite, getting it to emit smaller code than emscripten's old WASM.js path. Last I talked to you, there was maybe some lack of clarity on the long-term plans that you might have your own JS thing. So I was curious if you're still using WASM2JS, and if you are, whether you've noticed any of the changes, found any bugs.
So as far as I know, so yes, it was many months ago. We were like, we're not sure what's happening with WASM.js. We definitely saw everything you've done recently, and so we have all intentions of always using that if anyone ever wants JS and things. And so from our end, we haven't done a great job of documenting how to integrate it. And so this is more of like, if you are writing a Webpack app, or if you are writing a Rust web app, and you just want to see sample configuration for how to fall back to I11 without WASM.js and everything, we haven't done a great job of. We also don't provide the to get it to you easily. So like that's kind of like on the Rust deployment end, like we don't have great instructions for how to integrate it. And so in that sense, I actually don't think we're really using it that much in general. Like we were only barely using WASM to ASM, and that was just kind of like proof of concepts from a while ago. But I'm curious, anyone else here, have you all used WASM to JS or WASM to ASM or just WASM to JavaScript style business in the past?
Mostly just like for the example demos that we have of like, this is a tool that you can use, and yeah.
Well, we use Rust and WebAssembly in production, and one of the requirements from my manager was to provide fallback. So I used WASM2JS a bit, but it's not in production yet in our project. But it's from the user perspective, just.
Okay. Has there been any issues with that, with the kind of like the recent builds of WASM2JS? Has there been any issues so far in terms of integration, or
No,
it
it was like 2 or 3 months ago when I was working with this, and I created a prototype, and it worked for us. Not as fast as WASM, but fast enough to use it, and yeah. So it was before the refactoring of WASM2JS. I mean, I can run my tests again and provide a feedback about.
Nice. Okay.
Yeah, I'd be curious of any benchmarks or things, if anything seems slower than it should be.
I know exact numbers. Like we have a function which processes fixed amount of data. And I know the time which it takes in WebAssembly, and I recorded my old tests. Like it took around like 200 milliseconds in WebAssembly, and after WASM2JS, it took around 400 milliseconds. I also played with LTO enabled and disabled and different optimizations flags with LLVM. And I recorded all the numbers, so I can run these tests again and provide feedback about has anything changed or not.
Yeah, that would be good to see that data.
Oh, okay, great, I'll do it.
Just
in general, I'd expect. Oh, sorry.
No, go for it. Go for it.
And in general, I'd expect like a 2 times or so slowdown, just because obviously it's not as fast as WASM. But yeah, anything sort of surprising like 10 times slower or whatever definitely is something we need to look at. But I mean, any slowdown might be interesting if it's a surprising one.
Mm-hmm.
Yeah. The only thing I'd add on the subject of WASM2JS, which I'm not sure if we made this point clear or not so far, is again, similar to WASM-opt, we do plan on integrating this into WASM-Pack to have it automatically download and kind of provide an out-of-the-box solution for IE11. So yeah.
Cool.
And you also wanted to talk about how Emscripten is moving to FastComp, or moving away from FastComp to the LLVM backend?
Yeah. So we've basically announced recently that we feel we're ready to switch the default Emscripten to the new backend, and our plan is to get rid of FastComp eventually. The relevance here is, I believe, correct me if I'm wrong, that in Rust, there's a path. There are 2 paths that work. One is with FastComp and one is with upstream when using Emscripten with Rust. Is that still the case?
I think we still only basically largely support FastComp. I think it was you, Thomas, who added an experimental target which uses the upstream backend, but I'm not sure that ever came to fruition in terms of like a full supported target.
Exactly. Yeah, that was a while ago at this point, before sort of the linker was ready. So that didn't really go anywhere.
So I think we still only have we have a WASM and an ASM.js target for Emscripten, but it's basically the same thing where they're both using FastComp, and then we just call it a linker a little bit differently with how, or like the C compiler or the EMCC, whether we want WASM or not.
I see. Cool. Yeah. So anyway, so it's interesting that there's a target that's not fully supported, but I did get a few bug reports from users saying, "Oh, I tried upstream with Rust and it didn't work." So I guess people have found it, even though it's not, I guess, widely publicized.
Sure.
Yeah,
I'm
so,
kind of surprised actually as well.
yeah, so there seem to be a few bugs there. Anyhow, so thinking generally, from our perspective, we're trying to get rid of fast comp. It might be nice, but there are users, like I have users that I'm aware of using Rust with STL2 and other things in Emscript, and so maybe, I mean, from our perspective, the nice thing would be if Rust could stop supporting fast comp, and we would fix up the emscripten /Rust /upstream backend, which would mean that you could like kill the LVM 6.0 or whatever the fast comp one is. And if that makes sense to you, I think maybe we could help out with it. What do you think?
So I would personally love to do that at any time, and if the Emscripten folks, you guys are saying, please stop supporting FastComp. If anyone complains to us or breakage, we'll just tell them to redirect to you and for instructions of how to do things. That totally works for us.
Yeah, well, yeah, I mean, I guess I don't know where, but it should be documented somewhere to just like, I guess there's like a different target for it. There's like for the Emscripten with Rust with the WASM backend.
I'm not sure there is. Maybe we'd have to add that. Yeah, I don't know. The users who are complaining to you, I don't know what they were doing.
This is one. So we don't have any precedent at all actually for removing a target from Rust, and so like I'm not sure if like so the WASM 32 unknown Emscripten target would I would expect would just change to using the default LVM backend, and would just basically as long as you're doing it, it'll just continue to work, and you'll have to update your Emscripten toolchain, but that'll be pretty much it. I don't really know if the so I imagine Emscripten still has the ability to output JavaScript, but if you use the LVM backend by default, you're using WASM.js behind the scenes.
Exactly.
So if that's the case, the ASM.js and unknown Emscripten target is kind of a lie because it no longer emits ASM.js, but maybe it's like fine. And so that's one where like we could either just drop that entirely, or we could just change it to say it's not really ASM.js, but it's like JS unknown Emscripten or whatever, and that might work out just fine as well.
Yeah, maybe changing it is less disruptive. I mean, there's probably not that many users here, but maybe changing it is easier. But anyway, yeah, maybe we could take this offline for the details. But I kind of in the meeting wanted to even raise to see what the level of interest is and so forth. But it sounds like you are interested in getting rid of fast comp and fixing up, making sure the upstream stuff works with the MCC, etc.
I should be sure to clarify that this is like my own personal opinion from like also maintaining the Rust CI perspective, and so not building an LVM would be really nice. But in terms of like, I think this group in general, we tend to be. I don't think there's a ton of Emscripten users, and so this probably isn't super representative of the Rust community using Emscripten, and so that I suspect, I'm sure I will guarantee you there are people who care a lot about this but aren't here, or like we don't hear a lot from them over time, and so. It might also be good to make a post on internals, our internals forum, and that would probably reach more people. And if it doesn't reach them at that point, then it's probably fine to just change.
So it's a good place to raise this on that internals list and not say an issue on GitHub. Is that the best place?
Yeah, and basically just propose Emscripten's changing. We'd like to change the defaults for Rust, and it has just these consequences. And the stuff about building LVM doesn't really matter. That's more internal business, but more for like the user-facing side of things for a post like that.
Right. Cool. Yeah. So we can get that sent. Yeah.
Perfect. And if you all need help with the actual patch to Rust C or anything, I imagine you can figure it all out. But if you need any help, I can certainly help out as well.
All right. Thanks. Yeah. I'll probably be taking a look at this mostly.
Cool. There are just people come from time to time and they ask how to use Rust and C++ together. And it's not easy at the moment, but once a month or just from time to time someone asks. And for example, I have a use case at the moment, like how to use FFmpeg, and there is no pure Rust solution for encoding, and there is only one library which is compiled to JavaScript, because JavaScript runs faster than WASM for FFmpeg, as if I get it correctly from this repo. And well, I'd like to use Rust and C++ together, and if these updates which you are going to do, they will bring us this support, it would be really awesome. It would increase the use cases, like to use two languages together.
I suspect, at least for these changes being talked about, it probably won't affect it too much in the sense of, and Scripting has always been the solution for melding Rust and C++ together, and this is basically just kind of like tweaking how exactly Mscripten is working on the back end. And so it's like now if you pull the most up-to-date Mscripten compiler, it'll continue to work. But otherwise, in terms of like the WASM32, the non-Mscripten targets, just the pure Rust LLVM backend without anything else there, I don't think this would affect that story at all. It still would basically be incompatible with C++ because it's kind of hard to find a C++ compiler for that, or a C++ standard library for so.
And I think ultimately the answer for that side is WASI.
Yep.
Yeah, for kind of low-level C++, probably WASI makes sense. I think, and the scripting makes sense for things like SDL2, GL, all these system libraries that basically that's really all we focus on, the special stuff. Yeah, so it's probably kind of a niche thing to need EMCC with Rust, but hey, there's people with game engines using SDL2 and Rust.
Right.
All right, so we'll make an internals post, just gathering feedback on the proposed changes, and then yeah, Alex, I'll probably be in touch trying to figure out what's going on in the Rust code again.
All right. And I think, so for some, we've done this once before. I think we've updated the LLVM backend for Mscripten at one point, which like bumped the requirement for the Mscripten toolchain. I forget when that happened, or I think it just happened. I'm not really sure there was much fanfare around it. And then otherwise, the main thing to call out on that post would just be that the ASM.js target would either cease to exist or it would no longer produce ASM.js. It would just produce workable JS, one or the other.
Cool. Sounds good.
Cool. Yeah, thanks. I think those are the main items what we wanted to raise. Thanks for your time.
Yeah,
Thanks for coming, for sure.
Yeah. All right. So next is our usual goal status updates. And I don't have anything for Glue. I don't think anything's been going on. Anything in the multi-threading realm?
The PR is moving forward. Alex added some more comments, and I need to update it again. And we had some PRs merged in features, like some additional work with callbacks. So I need to update what they are according to this.
Cool. Oh, and I guess this is, since we're on the topic of futures, the futures trait is stable now, the stood futures trait. So do we want to talk now about plans for migrating to the stood futures, or should we kick that to a new agenda item for maybe next week or something?
Oh no, I think it's fine to talk about. I think we still have dependencies on some of the ecosystem crates, and so they haven't fully stabilized and released like fully stable versions on crates.io. And these are the ones there. We depend on more than just the raw feature trait. We still need like a channel and like some various support type like that. And
right,
so
but that's all in the futures crate itself, right?
Yes, but those are, and when I say they're not stable, I mean like they still have like alpha version strings and things like that. They're not like published as like a 020 or something like that. And so I think we might want to wait for that, for the ecosystem to kind of start having a published stable base as well. And then once we get there, I think it'd be trivial for us to just go ahead and add it all in.
Okay. Do you know anything about like what the status is of getting the futures crate to a non-alpha?
No, unfortunately, I don't.
Okay.
I suspect, I don't know, my guess is that by async await 138, everything will be ready. And otherwise, for now, it's just probably some final things here and there.
Okay. Yeah, maybe we can ping Yash about that. Seems like a good person.
I can also make some updates about features. At first, I tried to replace features future trait with the STD feature, and it worked. But at the moment, I opened an issue to update to futures preview 0.17. and because at the moment it fails to compile. And I think I can replace these features future trait with std, and I guess it will still work. And I also asked in Async Foundation channel what is the difference between std future and futures crate, and I got an answer that there are some extensions for futures which will not go into std. So we will probably need both std future and futures crate no matter when, because they will not go to the.
Yeah, because the futures crate just gives you all the nice helpers, and then std futures is essentially just the trait itself.
Yes, exactly.
It's like not even that. It's just the poll function. It's not even the nice things in the trigger. It's just the one function.
Well, not only future poll, but also task and waker, I guess, event context.
Oh yeah, those are like the core runtime system is in there for actually hooking all the events.
All right. Anything else about multi-threading stuff?
I guess I could say briefly, we've had some more interest start up on the Rust or the std-aware cargo side of things. And so one of the major things about threading in Rust and WebAssembly is we don't really have a great story for how we're ever going to actually ship this. And so that is a very strong candidate for being, just recompile std on the fly. And so that's becoming more viable, should I say. But there's still a lot of those. There's still lots of other things to work through. Like the standard library still has WASM bindgen specific hooks, which have got to go before we stabilize anything in the standard library. That is. But yeah, that's the only other status update I would have for that.
All right. I don't have anything for debugging. I don't think anyone else does.
Oh, interesting topic about debugging. I opened a few on WasmPack recently, just today, I guess, about debug build by default. We already discussed it, and the fun point that I've been developing a crate for a week or so, and finally I realized that I have integer overflows. And in Rust release build, it is silent, and in debug build, it panics. So I just realized that I got errors which were silent because the release build is the default. I'd like to bring an attention to this point. Maybe we can collect feedback and think about it a bit.
Do you have a link to the WasmPack issue where the discussion is happening?
Yeah, of course.
We throw that in the agenda. I don't really have anything to add in this meeting now, but I would like to review that discussion again.
I think we have an existing issue as well for this, right?
Yeah, I think that's the issue being.
Or not the one that you just opened, but we had. Let me just try and find it.
I posted it to chat.
Oh, I guess not. Never mind.
All right. Oh, sorry. What was that?
We discussed already default builds, like whether it should be released or debug. So it's.
All right. Moving on to toolchain and workflow polish. I have an update, which is that in one of the recent refactorings of WASM bindgen that Alex has been doing in order to support WebADL bindings directly instead of kind of be feature compatible with. One of the, we have got many nice things, but the things that went away was kind of detection of when we don't actually need bindings, like we're just passing, signed integers or floats or something. We don't actually need to do any argument shepherding. Is we still generate like a JavaScript shim that doesn't do anything but call into the WASM. And so one of the things I've been working on recently is trying to fix that so that we just export the WASM function by default from our ES module. And that is going nicely. Anything else?
Yes, at the moment we include the file section in package.json. And the problem is that we have snippets folder and it is not included. There is an issue for it. I just need some opinion on it. Because it is, again, this issue was already discussed previously. And
yeah, so I think, personally, I think that we shouldn't have the files field in package.json because it's caused us so much issues. And whenever things change, like downstream in the toolchain, or I guess upstream in the toolchain of WASM-Pack, like WASM-Pack tends to not get notified in time for there to be user visible breakage regarding this files stuff. But I believe Ashley had stronger opinions about keeping it, and also has the domain experience about, you know, Node and package.json npm stuff. So yeah, I would like to get more information about why she has that opinion, or if she actually still does, which was my understanding that she did. I don't want to put words into her mouth.
the fun moment here that if we remove files field, that we have git ignore, which just git ignore with 1 star, so ignore everything. And if you remove files, it will not publish anything at all.
I imagine we can fix those both at the same time, though, if we decided to fix one.
Yeah. I wonder if we put the git ignore not in the pkg directory, but up above, that might do it. Or also, like, we could probably just glob everything and throw it in files ourselves, instead of trying to manually put one thing at a time. Yeah. So. All right, anything else? I think that's something we can't resolve right now in this meeting. So we can ping Ashley and see what's up there. And I don't think there's any updates for monitoring, profiling, and testing infrastructure. No?
I continue to not feel super great about WASM bind gen test. It's just annoying to not be pound test, but that just came up in some random PR this week. So I mean, there's nothing we can do about it, unfortunately.
Right. There's also been no progress in the ERFC for the testing frameworks, so we don't really have an alternative.
Yep. It's good enough for now. I mean, it works. It works if you're writing very WASM specific things. If you're writing anything that's not WASM specific, it's just not going to be a good time.
Can you throw a proc macro attribute on a whole module yet?
No.
Okay.
And it's unclear if you will ever be able to do so. I would probably be the one standing in the way of ever being able to do so.
Yeah, that would be a way that we could kind of work around this, but alas.
You're not wrong. Yes.
All right, well, that's everything on the agenda. Are there any last minute topics of discussion that anyone wants to bring up?
So I have a update on the bulk memory thing from last time. The linker is now able to emit the passive segments, but it doesn't do so by default in quite the way I want it to eventually. So I'm still working through getting that all working in Scriptin, and I think once we have it stable in Scriptin, I'll ping you guys on that issue and give you the details there. And then I also have a random question. So the CG recently voted to move a feature detection proposal to stage 1. So we're doing feature detection, and so I'm wondering, Clang has a feature called function multi-versioning, where you have different implementations of a function for different architectures, basically, or different sub-architectures. Does Rust support that? Because that might be a user-facing way to use the feature detection stuff.
So this is where we don't have direct support for function multi-versioning, but we do have support for compile this function with these features enabled, and then that's it. And so that's all we have. I think multi-versioning is kind of like a little bit of a layer above that, where like it creates a function shim that does the dispatch for you, and you just call that. So we kind of have the lower level, but we do have that in saying we can. There's a way to express on x86 today. This function has AVX512, nothing else does, and so presumably. Like if what you're thinking in terms of like if we could get a story where it's like this function has SIMD128 and this one doesn't, that would be perfect. We would love to have that.
Okay, great. Yeah, that's the direction I'm thinking of going in. So yeah, making sure that works on Rust in addition to C and C++ is obviously important. So yeah, that's good to hear, and you'll probably hear more about that in the future at some point.
Nice. And so that way, yeah, that would basically the only thing that we would need on our end is we largely rely on runtime feature detection for that. So there has to be some way to detect at runtime whether it was enabled. So I imagine that would be like some Clang intrinsic for like some global is set somewhere to whether the feature check passed, or like whatever the LVM or whatever the WASM instruction would be for like check the 5th feature gate and whether it returned true. We just need intrinsic to be able to get that value.
So the problem is this can't really be done at runtime, because if you have a v128 in your instruction stream and you're on a target that doesn't actually support SIMD, then it's not going to validate.
Well, but this is in terms of like, there's like a section that has v128 stuff, and then I at runtime get to decide I'm either going to call the 5th function in the v128 section or the 10th function in my section, which is like the fallback. But I just have to know which branch to take.
The way we're thinking of doing it is basically that's decided at module instantiation time. So yes, there's a section with the MVP and a section with the SIMD version. But then when you instantiate the module, the engine, which knows what features it supports, obviously, sort of opts into using the SIMD one. And so the user code never like does a branch and decides to use one or the other. It just calls the function as normal. And if the engine supported SIMD, then it would have instantiated the module to use the SIMD version. Otherwise, it would have used the MVP version. So it's on the engine, but it's not quite at runtime in the same way. So what we'd really need is for the Rust compiler to just emit, and this will be like in the object format and everything, but basically to tell LLVM that both exist simultaneously, and just add the metadata or whatever it is, mangling maybe, to say that no, this one's for this target and this one's for the other target. And I think LLVM will probably handle it from there.
I think we could manage that.
Okay.
Figure that out.
Cool. Sounds good.
And for the LLD changes you were talking about with passive segments, do you know, are those all landed for LLVM 9, or will they be planned to be in LLVM 9, or is it just kind of trunk whenever it happens?
Yeah. I don't remember exactly when the LLVM 9 branch point is, but these things are all imminent enough that, yeah, I would expect them to be in LLVM 9.
Okay, cool.
Yep.
And we don't mind, we can always backport small features for WASM as long as it's not like 6,000 lines in LD. We should
yeah, no, it's, yeah, should be pretty straightforward.
All right, cool.
Cool, thanks.
All right, anything else? Last call?
I was, I was at a Unity hack week last week doing Rust WebAssembly stuff, and I don't know, it was just really cool to see like the stuff they were doing. They were, I don't know, the use case I saw was they were taking C#, compiling it to C++, and then compiling that to WASM. via like a long chain of compilers and things. So that was always fun to see. It was a good time. But they're very interested in the WASM time with like CreenLift as their runtime. They're interested in not so much the Rust and WebAssembly. They're still using a lot of just kind of like raw, their own bytecode stuff. But that's all fun stuff. And then otherwise, WebADL bindings just continues to be a pretty interesting thing for Rust itself. And so we're continuing to make slow progress on WebADL bindings, WebADL, whatever it's called nowadays, snowman bindings in various aspects. And so we don't have a ton of news as far as I know, or like big demos or anything, but we're working on things just to give a general status update on that.
Yeah, did you see that the proposed meeting time is exactly when this meeting happens?
I saw the proposed meeting time, and I didn't put 2 and 2 together until I saw your comment, and I was like, oh, oops,
Yeah.
that might not work out well.
Oh, well, we'll figure it out.
Yeah.
All right. Well, thanks y'all for coming to the meeting, and see you around the internet and next week. Bye.